863 words, within the 5% target range, 855,945. Here's the script. The slow-tearing reason your own continent hides a widening crack beneath your feet, and in 1861, it swallowed an entire stretch of Siberian shoreline overnight, dropping pastures, herds, and sleeping families straight into freezing black water before a single person could run. That crack never closed. It never even slowed down. Right now, this second, it is still pulling apart under a lake most people have never heard of. That lake is Baikal. And what's happening underneath it isn't a metaphor. It's the same raw mechanism that splits continents in half, the exact process that once tore Africa away from Arabia and poured in the Red Sea. You are standing on plates like this one. Everyone is. Most rift zones move so slowly you'd need a century to notice. Baikal is not slow. Scientists have watched it widen in real time, year after year, and they cannot make it stop. They can only measure how fast the ground is disappearing. Lake Baikal is the deepest lake on Earth, over 1,640 meters straight down, deep enough to hide the tallest skyscraper on the planet with room to spare. It holds roughly 20% of all the unfrozen fresh water on Earth's surface. But depth isn't the strange part. The strange part is why it keeps getting deeper. Baikal sits inside an active continental rift, a place where two slabs of the Siberian crust are being physically dragged apart, millimeter by millimeter, year after year. GPS stations bolted into bedrock on either shore have clocked the pull at roughly 4 to 5 millimeters a year. That sounds small. Multiply it by 25 million years, and you get a canyon so deep the lake floor sits below sea level, still sinking, still spreading, still open. Here's the part that breaks the peaceful, gradual story. Rifting isn't supposed to announce itself. It's supposed to creep. But on a December night in 1861, the Tsagan steppe dry grassland on Baikal's shore, home to herders and their livestock, didn't creep anywhere. A massive earthquake struck, and within hours a 200-square-kilometer section of solid ground buckled, sank, and vanished under the lake. No warning anyone recognized in time. Villages that existed at sunset were underwater by morning. Today it's called Proval Bay. Proval means collapse. The rift doesn't just widen quietly. Sometimes it lets go all at once. That's the twist scientists are still wrestling with. For decades, Baikal was treated as a textbook case of slow, orderly stretching, the kind of geology you could set a clock to. Then came the seismic swarms. Then came submersible dives. In 2008, a magnitude 6.3 quake near Kultuk on Baikal's southern tip sent shockwaves through towns that had assumed the rift was sleeping. Around the same time, crude submersibles descended into the lake's deepest trenches and found something nobody expected down there. Active hydrothermal vents, methane seeps bubbling straight out of the fault lines, and water chemistry that shifts near the rift's spreading axis. Evidence the crust itself is venting heat from far below. Researchers now track dozens of micro-earthquakes every single month, most too small to feel, clustering directly along the rift's edges. A constant, low-grade signature of rock tearing apart beneath 25 million years of accumulated sediment. Some geologists project that if this rate holds, Baikal won't stay a lake. Over the next 20 to 40 million years, the rift could widen enough to let ocean water in, turning inland Siberia into a coastline the way the Red Sea once turned inland Africa into one. It has happened before, on other continents, at other rifts. Nobody alive will see the ocean arrive, but the machinery for it is already running, right now, underneath sailboats and fishing villages that have no idea they're sitting on a coastline still being born. What makes this different from ordinary earthquake risk is the timescale mismatch. Continents don't ask permission, and they don't wait for infrastructure to catch up. The same rifting physics is active right now under East Africa, where researchers have watched cracks open across roads and farmland in a matter of days, not centuries. A preview, some argue, of exactly what Baikal did in miniature back in 1861. Monitoring networks can log the millimeters. They can map the faults. What they cannot do is predict the moment stress stored along a locked fault segment releases all at once, the way it did on that December night, when a quiet grassland became open water before anyone understood what was happening. That is the uncomfortable honesty behind every GPS station on Baikal's shore. They measure the crawl, not the lunge. So the crack keeps opening, millimeter by millimeter, logged and graphed and utterly unstoppable, while the villages, roads, and rail lines built along Baikal's edges sit on a fault system that has already proven it doesn't always move slowly. The real question the data still can't answer is which stretch of shoreline is storing that same silent tension right now, quietly locked, quietly loading, waiting for the night it decides, without warning, to let go the way Tsagan Steppe did in 1861.